Hello, my name is John Kelly and this is the Weber Auto YouTube channel. This is the fourth in a series of videos on the evolution of the Toyota Prius Hybrid Transaxle. The transaxle we will be looking at in this episode is the P510 transaxle that comes in the 2012 through 2017 Toyota Prius C, the city small version of the Prius. Now the P510 transaxle is almost a twin of the P410 transaxle that I have a separate video on. As a matter of fact, I have two videos. I have a relatively quick look video of the overall operation of the transaxle, and then I have what's called a deep dive where we go through all of the individual pieces and assemble the transaxle most of the way. In this video, we are not going to totally disassemble and reassemble the transaxle. Instead, we are just going to look at what's different between the P410 transaxle and the P510 transaxle. So if you've not seen the P410 transaxle, now would be a good time to go watch that and then come back to this. Now here on the bench, of course, is the P510 transaxle. Right here on the very bottom, this is the bottom of the transaxle. I've highlighted it in yellow here. There's a casting that reads P510. So P510 indicates this is the fifth version. The 5 indicates it's the fifth version of this transaxle. Now the P410 came in the 2010 through 2015 Prius and 2012 through current Prius V and 2012 through 2015 plug-in Prius. There was a P310 that came in the 2006 and above Toyota Highlander, and there were different versions of that. There was a P311, 312, 13, 14. That's used all the way up through the new RAV4 hybrid vehicle. All of those are based on the same overall design. Some are a little more heavy duty than others, and this is by far the lightest duty of all the versions. This transaxle only weighs 176 pounds, which is a whole 100 pounds lighter than the version that comes in the Highlander, the Avalon, the Camry, the RAV4. This system, the Prius C, only runs on 144 volts rather than the 201 or clear up to the 288 like in the Highlander. The maximum system voltage on this one, coming off the rotors, the MG1 and MG2 rotors for regenerative braking and for driving down the road, is 520 volts rather than the 650 volts that we had in the P410. So just a smaller, lighter weight version of the transaxle. This transaxle also has the 3-digit code on it, like we've discussed in previous transaxle videos. This one is right here and reads 1LM. 1LM. So the P410 was a 3JM. The P310 was a 1JM. So there's a 2JM in there somewhere, and probably later ones. The 1LM means it's the first version of this smaller transaxle, and it's a different design. So the second letter there, or the second digit, the L, is first digit is the generation, second digit is the style of the transaxle itself, the variation of the transaxle. And the M, I have nothing to prove what it means, but I'm sure it means it's an electric motor style transaxle. All right, so the things that are different between the P510 for the Prius C and the P410 in all the other Priuses up until 2016 Prius and 2017 Prius Prime. Let's look at what those differences are. So first thing when you open one of these cases that is quite obvious that there's a difference are the stators, the stator windings. So this is the MG2 stator winding, and as you can see, it's quite a different design. They use flat wires in the windings rather than round wires, and these flat wires are much larger, which means they can handle much higher amounts of current. Now, because these flat wires are larger, there's fewer turns of wires in the stators, and electromagnetic field strength, among other things, is affected by the number of turns of wiring around each lamination there, but also the physical size of the wire and how much current can go through the wire. And there are other things also, but the larger wires mean fewer turns, but the larger wires also mean a lot more current can exist in those wires. Now, if we were to look at a previous design stator, like I've got one in the vise right here that we've cut away. This is a cross section of a previous design stator, and you'll notice we have much smaller copper wires. I haven't counted them, but in just glancing at the three different phases that are insulated by the paper here, so there's 1, 2, 3 phases of wiring on each side here. I would suspect that there's, I don't know, 100 individual wire strands, which means 100 turns of wire. But the wire, of course, is extremely small, which means the amount of current that can go through those wires is very small, relatively speaking. So this newer design stator with the flat wiring is unique, or was unique, to the new or to the P510 transaxle 2012 and above. But now, which you'll see in the next video on the P610 transaxle, they use the flat wiring in the P610 transaxle for the 2016 and above Prius. So very interesting. So this is the MG2 Stator assembly with the flat wiring, and let me bring in the MG1 stator here. Notice it also is using the flat wiring. It's just not quite as wide as the MG2 stator. Now, this is not the first time I've seen flat wires in a stator. Honda hybrids, for their integrated motor assist systems in 2006, went to the flat wiring for their little electric motor that was sandwiched in between the internal combustion engine and their CVT transaxle. And of course, it was a much larger diameter stator, but it was also the flat wiring. I don't think the wires were as large as these, but they were the flat wiring. All right, so for differences, both stators are different. All right, as far as the rest of the case is concerned, the only thing that's different on the entire rest of the transmission case is, well, there's a couple of things. One, we don't use an electric shift actuator. We use a cable to shift the transaxle in and out of park. The other thing is, and you would have to look at another transaxle, another hybrid transaxle to maybe even pick this up, is that there are no cooling passages. There's no antifreeze that runs through this transaxle, through any of the parts of this transaxle. That means that the cooling of this transaxle is done by radiating the heat off of the case out into the air, which the fluid, when I opened this one up, was really dark. Now, it could have just been, and stinky, like hot stinky, It could have just been the driver of the vehicle was aggressive that this transaxle came out of, because I just got it from a salvage yard. Or it could be an indication that these transaxles run hot. And since there is no external cooling system that helps cool the transaxle, that's a possibility, but Toyota usually does a really good job of designing things, although they're not without the chance of making mistakes. The other big change that's on this one, which does affect the cooling system, or the ability to cool the stators and the rotors of this transaxle, is the oil pump assembly. Okay, so right here is the trochoid oil pump out of the P410 transaxle that all the Prius hybrids use. And you'll notice its height, its width there is pretty small. This is the trochoid pump out of the P510. And you'll notice it's a larger, or it's thicker, which means its volume output will be higher, but you'll notice the diameter is equal. So I haven't put two of these together, but it looks like it's twice the height of the previous transaxle oil pump. Now what that means is they're using the oil pump to circulate a lot of fluid across the stators that we've looked at and the rotors to help cool them. A lot of, well, twice as much fluid. But remember, this pump is only activated when the engine, internal combustion engine, is running, which honestly is most of the time, unless you're doing just a little bit of around town driving. Okay, so we know that there's a higher volume oil pump on the P510. Now let's take a look at where that oil is pumped. So we know that the stators need to be cooled. And what they have, an interesting thing inside the transaxle, is they have some passages where they have these tubes that bolt into the passages. On the bottom of this tube, you can see there's a hole right here and a hole right here and a big hole right there. What happens is fluid from the oil pump comes into this big hole in the top of this tube, and it's pumped out these little holes, one in the back of the MG2 Stator assembly and one in the front, to drip oil down into the windings, the coils of the stator, and of course to get to the spinning rotor down inside as well. So if we look at the case, we've got the same design of oil catch system and the parking pawl and linkage and the oil pump screen and pickup tube. But then right at the top up here in this oil catch system, this tube that cools the stators pokes through this hole and is bolted in place. And this is for the MG2 stator. The MG1 stator also has a tube, a cooling tube just like that. So now here on the other side, where the tube comes through, you can see the end of the tube right here. It sticks through and will drip oil or drop oil down on the stator assembly for MG2. Okay, so we're ready to put MG2's stator back in the case. This one, instead of being held down with 3 long bolts, has 1, 2, 3, 4, 5, 6 shorter bolts that hold it in place. These little wires here, the 3-phase wiring, they are very delicate. We've got to get those matched up with the junction block here. Okay, so let's install this. Set it up in place. Line the bolt holes up. Get one partially started to hold the rest in. We've got a temperature sensor right here for the stator temperature. All right, then you can see right here we've got the three connections for the stator to bolt to the junction block and our high voltage three-phase cabling out here on the end. Once again, those bolts and all the connections need to be clean, dry, free of oil from your skin, transmission fluid, all of that when you bolt them together and establish that electrical connection. We don't want anything in there that can create a voltage drop and rob power from the system. So I'll plug in the temperature sensor. And now we can see, if I turn the transaxle sideways here, you can see right here is that tube, the cooling fluid tube that came through from the back side of the case. But notice it drips into this plastic channel right here, and that plastic channel has holes in the bottom of it that distribute the fluid somewhat evenly down through the stator windings to try to keep the stator cool. So that's the same on both the MG1 stator and the MG2 stator. They both have those cooling pipes and channels. Now, this pipe right here is fed through an external pipe that comes right off the oil pump in the side cover. So we've got a banjo bolt up here to the top. The oil pump assembly has a fitting on the outside of it that will pump oil over to cool the MG2 stator assembly, and then it pushes it through also through that same tube into the other case half, the bell housing side, to drip down and cool the MG1 stator assembly. So, as I said, this transaxle does not have any external antifreeze style cooling to remove heat from the transaxle. It has what appears to be double the volume oil pump in it, and it simply uses transmission fluid to cool the stators and the rotors. And it uses the same world standard fluid that all the other hybrids do, except the very first generation, as far as Toyotas are concerned. Okay, let's look at what else is different on this transaxle. If I pull out this piece that I've cut away, this should look very familiar to you if you've seen my other video on the P410 transaxle. It's the exact same style of setup. The rotor here is just a tiny bit smaller for MG2. The MG1 rotor is a lot smaller. You can see it's a considerably narrower. The power rating on the P410, we had 80 horsepower. This one is 60.3. On the P410, we had 153 pound-feet of torque. This has 124 pound-feet of torque. But it still goes through the same gear reduction and torque multiplication, which results in an overall torque delivered to the counter drive gear here of 328 pound-feet of torque, which is approximately what the second generation Prius had. They had 295 pound-feet of torque. So this is 328. There's some frictional losses through the gears, probably around 5%, so minus 15. So it's a little bit more powerful than the second generation Prius, but considerably lighter. 176 pounds versus 244 pounds, so almost 70 pounds lighter. The final drive gear ratio is just slightly different. We have to get one rotation of the final drive ring gear and the tire, which is connected to it, or turned by it, we have to turn the MG2 rotor 8.410 times, where on the P410 on the previous video it was 8.615 turns. So just a slight difference in the gear ratio, but other than that, it works identically to the P410. So let's just review here quickly the differences between the P510 and the P410. Number one, it uses 144 volts instead of 201.6. Number two is the power ratings are a little bit lower. Number three is it's oil cooled rather than oil and coolant through a heat exchange through the case cooled. Another one is our flat wiring on our stators is different, and of course, because we're using oil to cool things, the transmission oil pump volume has at least doubled. Oh, the other thing that's different on the Prius C is it uses the original Toyota Prius first and second generation Prius engine. The 1NZ-FXE is also used in the Prius C. So it didn't get the newer 2NZ engine. It used the previous one, which I'm sure was less expensive. The Prius C is the least expensive hybrid that Toyota has for sale, at least here in the United States. So that finishes up our review of the P510 transaxle and how it is just slightly different than the P410 transaxle. In our next video that I'm excited for, we will cover the brand new P610 transaxle that comes in the 2016 Prius and the 2017 Prius Prime. So I look forward to reviewing that transaxle with you. Thank you for watching.